Hey, everybody. So, welcome. So let's start with a couple of questions, get things kicking off. Who here has an electric vehicle? Nice, nice, loving it. Melbourne's a good city for it. Second question, who here has a Tesla? Oh, hard luck, guys. Really sorry about that. No, just kidding. I have an Ioniq 5 at home. Big fan. Beautiful car, beautiful car. Anyway, this isn't actually going to be about the cars, sadly, if that's what you've come for. So I'm going to show you guys how to build a map server using Postgres, PostGIS, and a bunch of other open source tools today. Look, I'm not suggesting that anybody runs out, gets rid of Google Maps, creates their own map server and just runs self-sufficiently off your own kit forever. That's not what I'm saying here. What I'm going to do is I'm using this real-life use case to demonstrate the power, the features, and the functionality of Postgres, PostGIS, and open source tools around this stack. So we'll kick off. Oh, I do this every time, don't I? There we go. So just a couple little tiny bit of introduction. So as Lars said, I do work for EDB. I'm a solutions engineer at EDB. Only thing you need to know about me is I absolutely love gardening and I absolutely love Lego. So they're my two, and of course electric vehicles. So they're my key interests. And I work for EDB. So very quick word about EDB. EDB are the largest contributors to open source Postgres. So we also support Postgres running on-prem, in the cloud. We have a fully managed service. Postgres everywhere, all at once, is how I like to think of it. So yeah, that's EDB. You need any Postgres? Give us a shout. So a little bit about Postgres. Now, thankfully, being a data engineering audience, I don't normally have to give too much detail on this because you guys know Postgres. You know Postgres, you love Postgres. You love that it's so easy to use, so easy to install, bring it up anywhere, shove it in a container. It's just super easy, super available to use. What we're going to focus on today as the advantage of Postgres in this context is its extensibility. So what I mean by that is the ability to build extensions for Postgres because you have access to the code, you have things like user-defined data types, user-defined indexes, and you can build things like PostGIS or PostGIS in the Postgres ecosystem. Now, PostGIS itself, so it's been around for over 20 years now, really solid piece of software. It was actually developed by a Canadian company, and the reason they built it on Postgres was because they felt there was no other platform that had the power and the flexibility of that database engine to actually build such an amazing spatial data software on top of it. So, of course, bears repeating, we are focusing 100% on open source software today. Little bit about the mapping data. So explain to you guys up front, I am storing all of the mapping data in my PostGIS database. So I'm not taking a mapping layer, I'm not getting Google Maps or anything and just putting some JavaScript on top. All of the mapping data that you're going to see is stored in the database. Now, I think that's just phenomenal. So I'm using OpenStreetMap data. OpenStreetMap data is, again, another open source data set. It's a community project, been around for a very long time. Notable users of OpenStreetMap include Facebook, include Tesla, interestingly enough, in the navigation in their cars. I don't know if any of you guys have ever played Pokemon Go, but the mapping data under that is all OpenStreetMap data. Anyway, very widely used, very well-respected data set for mapping. The other thing I've put up here is just to bear in mind as we go through about the data structures that we're going to be looking at in terms of the data we're storing. Standard spatial stuff, guys. So nodes, point locations, ways, which are lines between points or line strings in terms of spatial data, relations and tags, which you can just consider as metadata. And that's pretty much all you need to know on that score. So, in terms of setting up the actual tile server, now I'm not going to bore the crap out of you guys by doing a bunch of yum installs and taking you through a bunch of repos. That's just rubbish. What I've done here is this is the list of steps that I go through to set up the actual map server. So it looks like quite a bit, but it's actually fairly simple. So you just need to install Postgres, install the PostGIS extension, import your spatial data to PostGIS, and then I'm using Apache 2 to serve that data, and I'm using render-D as the rendering piece which queries the data in PostGIS and serves it up and means we can see it on the screen. The other thing to note that I'm using is Leaflet. Leaflet is a JavaScript layer that I'll be putting into my HTML to take the GeoJSON data I'm going to get out of my PostGIS data and represent that on the browser so you guys can see that. So, bearing all of that in mind, let's do this live. Let's not do the screenshots. This is my map. So you can see this is live. We're loading through now. You can see this is a slippy map. I'm just showing you basically so that you can see that the actual map's there. Just having a little slight issue with the renderer there, but that's not a problem. So what I'm going to show you guys first is we're just going to do a really, really simple, we're just going to have a quick look at why that's just come off there. Sorry guys, just bear with me for just one tiny second, I promise. This is very unfortunate, but just bear with me.
Did you not sacrifice anything to the demo gods today?
Well, I usually do, but it's been working so incredibly well all day that that's mildly unfortunate. That's not a problem. Alrighty, guys. So we'll let that have a little go on that in the background. In the meantime, let's get back to the presentation. So can you guys see that up there? Sorry about that. Sorry about that, AV guys. Okay, cool. So the map runs the PostGIS data. We're just going to go through, and you can see. So I'm just putting a simple marker for home on my map there. So the way I do that is I take the coordinates of my home base, which is where I'm keeping my car. That's where I'm storing my car, and we keep that on the map. So going through here, the next thing we need to do, so we're going to import our charging station data straight into Postgres. So what I've done here is I've used data from the New South Wales Transport for New South Wales Open Data Store. So this just comes as coordinates. So one of the things to note about spatial data, coordinates by themselves do not actually constitute spatial data. Now, the reason for this is when you look at different models of mapping of the Earth, so you have, say, for example, Euclidean maps that are, presented as a flat screen, or you have spherical models, obviously, that are, when you have 3D mapping models presented as a sphere, coordinates actually kind of work slightly differently and have different levels of accuracy and pinpoints of locations depending on what you're using. So when we use spatial data, we have to convert coordinates to the actual spatial data types that we're going to be using in PostGIS. So firstly, find your spatial reference system. There's a lot of them out there. 4326, which is WGS84, is the kind of default, the most popular one because it covers the whole Earth. Main thing to bear in mind is that you use the same spatial reference system for all of your data. So when I put this data into PostGIS, it's very, very easy to transform it into spatial data using the native PostGIS transform function. So going through here, you can see this is inserting the data into that table, and I'm simply using that transform function to take the coordinate data and store that data as the spatial data type. So you can see at the bottom there, that's what's in the table afterwards. That geom column on the end, that is the representation of our point data. Alrighty, so the next thing we need to do, we've got our charging stations stored in our PostGIS database. We've converted that coordinate data to spatial point data. Now we need to represent that on the map. So again, PostGIS is really, really, really good for this. So you can just take that spatial data and put it into an as GeoJSON function. Ask what you want what type you want the output to be, and it will output that data as GeoJSON for you. Once it's GeoJSON, you can then put that straight into your JavaScript layer, into your leaflet layer, and that's going to appear on the map. So this is the code. I just make a bit of a joke at this point. Super easy. This is actually quite a long stored procedure, right? This is all written in native PLPG SQL. But what this code is doing is I've given it a polygon. So imagine that you've got a web browser open. You want to know how many charging stations are in that screen, in that part of the screen. I'm passing that function a polygon in coordinates. There's no problem there. Passing that function a polygon, and it's going to come back and tell me which stations are in that polygon, and then it's going to put them on the map. So we've got the GeoJSON data for that. Let's have a quick look. This is obviously the small part of it. This is just an excerpt. I would have shown you that in my file if my VPN will come back on. We'll see how we go with that one. But this is the GeoJSON data that I then put into my leaflet layer, and it's going to appear on the map. So again, this is all done by native PostGIS functions. Super, super easy. And that's what you'd see. Charging stations are on the map at this point. So again, the borders of what you see there are the borders of the polygon, and it's brought back that point data as GeoJSON, and I can get that on the map. We will just have a quick look and see if we've got a connection. We do not, in fact, have a connection at this point. That's rough times. My apologies for that, guys. We'll have a quick look at the end again and see if we can get through. So in terms of the, what do you want to do with a charging map? So you've got your car at home. Poor old car. We've had a rough day on the solar panels. It's Melbourne-style weather. Pissing it down, really rubbish. And we've got no power coming into the car, nothing coming through the solar panels. 60 kilometers range left on the car. We need to go and charge it. So what are we going to do? We're going to look and see which stations we can reach with our 60 kilometers range we have left on the car. So again, we've got our coordinates of our home base that we used before to set up the marker there. And we're going to pass that into PostGIS and say, what's in the range of 60 kilometers? So this is that code. Again, and I know I keep saying it, and I'll say it 5, 10, 15, 20, 25 times. It's so incredibly simple. So we just have a within function in PostGIS. So I've given it, again, my coordinate data, because it's going to handle that for me as well. And I've just said, tell me which stations are within 60 kilometers. They do it in meters. That's why it says 60,000 in the query. That's brought me back 13 points of data. And that is the list of the charging stations that are within 60 kilometers of my house. I'm like, fantastic, I know where I can go. Next thing, maybe you want to know which ones are the nearest. That's probably a fair thing to do. So for that, we're again going to use a native PostGIS function. We are going to use a distance function. So we're passing it again, the coordinates, but this time we've put in the 60 kilometers and we've said, bring back the distance and bring back also the type of the metadata that's around those points to see, can we go to that charging station? Do we want to go to a Tesla charging station? Who knows, maybe you might like that. But that's what we can do with this function. So the next thing we're going to do, very, very exciting. So this is another open source extension for Postgres called pgRouting. I understand we're Australian, we might pronounce that differently, so you can laugh if you like. pgRouting is an extension that effectively provides a network topology on top of your spatial data. So this is a very fancy way of saying it's going to take your point data, it's going to take your way data, so you remember your lines between the different points. It's going to take all of that and put it into a network topology, which is effectively a nodes and edges system, right? So let's have a little look at the underlying data that it brings out here. So just to add before we go in there, I've used a tool called OSM to pgRouting, another open source tool. And what that's doing, that is taking my underlying map data and it's enabling the pgRouting topology on top of it and storing all of that data in PostGIS. Again, this is all completely hands-off. And the other fantastic thing about that is it's not just storing the data, it's writing all of the indexes for me as well, which is an absolute godsend. So going through, let's have a little look. This is how pgRouting actually stores that data. So you can see in this table, you've got, this is the representation of a way, so the shortest distance between two specific points on the map. So we've got source coordinates, we've got target coordinates for where the data is going from and to, but we've also got other data in here like cost data, distance data, we've got speed data, we've got other data relating to roads like one way, for example. So all of this data together can be used to establish the most optimal route between two different points. So what we do with pgRouting and PostGIS is we can call functions that, depending on certain inputs and certain, so for example, you might be cycling, you might be driving, you might be walking, you might have certain points that you want to avoid. These are all things that you can input into the calculation algorithms to work out the most optimal route. So I don't know how many of you are familiar with the traveling salesman problem. This is fairly complex algorithm work that's going on under the hood here. Again, this is all available straight out of the box. Straight out of the box, open source, fantastic. So now we've got our pgRouting enabled database. We've got that network topology built into the system. What we're going to do at this point is we're going to say, find us the optimal route between our home base, where we've kept our poor car that desperately needs a charge, and our target, which is our nearest station that's not a Tesla station. Just kidding. I don't want to give Elon Musk any more money. No, it's all right. I'm sorry. I don't have an agenda, I promise. Alrighty, so how are we going to do this? So what we're going to do is we're going to call the Dijkstra function in pgRouting. Now, some of you might be familiar with Dijkstra's algorithm if you've done this sort of spatial data or traveling salesman work before. This is the function. All that's going to take from us really is our coordinate data to and from the different, from our home base to our target station. We've specified that we want it to bring back the ways, which are going to be each part of the route on the way down. And it's going to bring that out in a sequence so that they're all together. You can join them all together and it's going to establish a route. Now, what are we going to do with that data? This is going to spit out line string data, which is another spatial data type. I will note when I go to the next page, I don't know if anybody sort of noticed my little note at the bottom there. When we go to the next page, no, it's all right, we're not there yet. So that line string data, as I said before, I've been saying all along, we have to convert that data to GeoJSON data to put it into the leaflet layer that's going to go onto the map. We have a function to do that. We've used it before, that as GeoJSON data, we're going to output that to a file, and it's going to put all of that GeoJSON data in the right sequence for us to load into our leaflet layer, and it's going to appear on the map. Super, super easy, barely an inconvenience. So this is what we come out with. So there's our home base over in Brookvale there. There's our charging station in Chatswood. We just built Google Maps, guys. No, I'm kidding. So one question I do get quite often when we look at this stuff is, why is there no interactive layer here? Why can't you click on stuff? Why can't you do this, that, and the other? Look, I don't have time to show you how to build a PHP server as well as all of this, but you can absolutely feed real-time data into this, push, pull, whichever way you decide to do it. You can absolutely do an interactive layer using something like PHP, although I think that's probably a bit outdated for some of you guys these days, but what can I say? I'm a bit old school. And yeah, you can get your routing up onto the screen in an interactive fashion as well. The more eagle-eyed amongst you will probably notice that this little patch here, yeah, so we are in fact driving our car through a park there, which is probably not ideal. I should note that that is actually a genuine real path through that green land there. It's not actually just charging you straight through a field or anything like that. But this goes back to my point. You can absolutely customize the function to say whether we're walking, whether we're driving, whether we're on a bike. I haven't done that in this case because I'm presenting like bare bones functionality here. But that's totally something that you can write into the process as well. Alrighty, so just a couple of things I wanted to bring up about PostGIS before we finished, because there's such a huge amount of functionality in there, and I haven't scratched anything like the surface on this. In terms of integration, quite often when you're dealing with spatial data, you'll need to have a translation layer in the middle of your database and your application to kind of facilitate that spatial data functionality. PostGIS works very well with KML, so keyhole markup language, and works very well with the vector tiles as well, with MVT. You've seen the GeoJSON functionality already. One of the real strengths of PostGIS is you can absolutely plug it in anywhere, and it's very, very easy to integrate without having to have those translation layers in the middle, adding complexity and overhead. So that's one thing. Comprehensive support for lots of different data types. So PostGIS supports 3D data types out of the box, which is fantastic. There's also support for 4D data types. I like to make a little joke there and say, no, it's not time, it's not a temporal dimension. It's actually just things like if you wanted to store some further metadata, if you're doing a mining project, for example, and you need to know depth and density of materials, that kind of thing. Again, you can add all of that data into your data types, which is very cool. Anybody who's worked on spatial data before might know the pain of working between vectors and rasters. But with PostGIS, you can easily convert between vectors and rasters as you're going, so there's no issues there, which is very, very cool functionality. Indexing is another brilliant advantage of Postgres and specifically PostGIS. So PostGIS actually uses general inverted search tree indexes, or GIST indexes, based on bounding boxes and R trees. So effectively, that means you're sort of drawing boxes around types, if you can kind of visualize that. They go further and further down, get smaller and smaller and smaller. They're based on R trees, and they're actually self-balancing as well in the implementation in PostGIS. So they're effectively self-tuning, which is, again, very, very, very cool functionality. And the last point I like to make is, of course, this is all Postgres. This is all completely on Postgres. So when you have to pay tons of licensing for things like ArcGIS, for things like Oracle Spatial, for things like QGIS, it's worth bearing in mind that for a lot of use cases, PostGIS is incredibly powerful, and it's completely open source, and you could totally use that instead. So this is just trying to, open up those doors of options and functionality, and just try and show you guys a little bit about what you can do with this software. I am going to be very brave and see if I can get another connection here. I am slightly concerned that, hey, would you look at that? Oh, fantastic. Okay, bear with me, guys, because we'll just show very quickly. We'll just really quickly show, hopefully you won't see too much here, but don't give me any grief for running as root. I don't want to hear it. I'm not interested. slash HTML index. Righty. Yes, I want to open anyway. Okay, so this is actually my file. So the things that I refer to here, you've got, so this is obviously just a standard HTML file, right? Things like putting the marker in. So that was the home marker that we used. This underneath here, this is all the GeoJSON data for the charging stations that we queried and put in here. So that's all there as well. Then down here, we also have, let me just get rid of these comments so you guys can see. This is that line string data for the routing. So you can see Postgres has literally just output that line string data for me, put that into a file, and I've literally just copied it in here. Super, super easy to use. So let's just get rid of that other comment. This is the route. You can obviously understand how it kind of works, establishing each different bit of the route as you go along. Let's save this. Now, come on. Yes, there we go. That's our map. So that's our route live on the server. Fantastic. So at least I did get to show you guys that it does in fact work.
It's still going through the pack though.
There we go. This is my tagline, for any questions or a chat or anything, or a friendly or unfriendly chat about Postgres, I'm here.
Thank you, Lizzie.
Thank you.